Hello friends, welcome to Coding Interviews channel. Hope you are doing great. If you haven't subscribed to the channel yet, please go ahead and subscribe. Also, I have created a bunch of playlists to cover various categories of problems such as BFS, DFS, dynamic programming, stacks, queues, linked lists. Please check them out. I have uploaded the code for this problem to the GitHub repository. You can find the link from description below this video. Let's jump into today's problem. Count number of homogeneous strings. Given a string S, return the number of homogeneous substrings of S. Since the answer may be too large, return it modulo 10 to the 9 plus 7. A string is homogeneous if all the characters of the string are same. A substring is contiguous sequence of characters within a string. So basically, we are given with a long string and we are asked to return the number of homogeneous strings, right? Substrings basically. So a substring is a consecutive or contiguous sequence of characters, right? So we will assume the characters in the given string are all lowercase for the example, right? So what is homogeneous? Homogeneous means a string with same characters, right? So every character should be same, right? That's when we'll call it as homogeneous, right? So string will have lowercase, that's an assumption, and homogeneous is all characters should be same in a given string, right? So in that particular case, let's see how many strings or substrings are possible for this example string, right? So let's take this example, the same as example one. There is a little bit not clear in the explanation, so that's why I want to make some things clear here, right? So how many strings or how many homogeneous strings are possible, right? So in order to go to the homogeneous strings, let's first decompose this into how many strings that are with same character, right? So with single character, how many unique strings are possible? So out of that, A, that is one string, and then BB, that is one string, CCC, that is another string, AA, right? So that means if you just copy this and break it up, right? So basically we will say the same thing, whatever I have come up with, right? So just break it up like that. So A, BB, and CCC, AA. So there are like four strings which are homogeneous, right? But within this, within this, there are multiple different strings of different lengths are possible, right? There is no homogeneous length is not given, right? So everything is given length of one is called a homogeneous substring, right? So our task is to find the number of homogeneous substrings. So here, this is one level of decomposition. So a given string is divided into these many homogeneous strings, but each of them could have multiple homogeneous strings, right? So if the character number of characters in a string are like more than one, there could be more than one homogeneous substring, right? But in this case, A, this is one character, right? So how many homogeneous are possible? Obviously just one. But for BB, how many are possible, right? So there is B and BB, right? So that means two are possible, right? As simple as that. So B and BB. And for C, this is interesting, right? So this is like there is C and CC and another CC. So a CC with these two and another CC with these two, right? And there is CCC. And previously here we said two are possible, right? In fact, it's not two, but there are three. Why? We'll come back. So basically, there is a B, right? So there is this one B, that's one string, and there is another B, that's one string, and all B's together, that's another string. So the three are possible. In here, C is possible, the second C is possible, third C is possible, and CC, basically the first two, and then second two C's, right? And C C C. How many totally? There are 6, right? So 6 strings are possible. And for A, this is the last one. So for this, A, A. So it will be 3. So totally, it will be 13 strings, right? 1 plus 3 plus 6 plus 3, right? So that's how it is. But for the first decomposition, it is clear. As and when you have the character is not same, you can break it up and you can count the number, right? So now, if the number of characters in a string are more than one, what we should do is the question. So if it is one, it is one, that is clear. A and 1, that is clear. But if it is 2 characters, the answer is 3. If it is 3 characters, the answer is 6, right? So how we are going to come up with this number? So BB is 3. So if the string length is 2 characters, how to get the answer 3? If the string length is 3 characters, how to get the answer 6? Right? So if you closely observe, right? So if you closely observe, let's take this example, right? So CC. So how many strings are there of length 1? Length 1 is equal to 3. And length 2 is 2. Length 3 is 1, right? If you follow, so length 1, so C is 3, right? That's what we said, 3. So out of this, how many strings are possible, or how many homogeneous substrings are possible of length 1? 3. How many homogeneous substrings are possible of length 2? 2. These two, right? How many homogeneous substrings are possible of length 3? Only 1, right? So this is what the better picture of this. So what essentially that is, right? So whatever the number that we got, the string length is 3, right? Initially, the length is 3. So that means length 1 will be 3, length 2 will be 2, length 3 will be 1. So if you add all these together, 3 plus 2 plus 1 is 6. So this is whatever we wrote, this is just another representation to do like this, right? Length 1 is 3, length 2 is 2, length 3 is 1. So if you look at that, right, it is essentially, if you have a length n, right, you just add up those numbers which are adding up to n, 1 to n numbers. Let's say if the length of the string is n, right, the length of the string is n, where n is the length of the homogeneous substring, okay, not the length of the given string, okay, don't be confused with the n is length of homogeneous, right, string, or we'll say substring in this case, right? So if that is the case, how many homogeneous substrings are possible in total, right? Then what we will say is n into n plus 1 by 2. So this is the formula that we are going to use. It is as good as sum of the first n numbers starting 1, right? Starting with 1. That's what we can say. So that's the formula that we are going to use. So it is a two-step approach. First step, we are breaking that up into the homogeneous big string, and in that big string, how many number of substrings are possible out of that. That is the second step. So this is our first step and this is our second step. So in the first step, we just look at how many are possible at the uber level and then go down to the other level. And one more thing that we need to give attention to while coding up is the answer may be too large and we are asked to return it modulo 10 to the 9 plus 7. So this is another thing that we need to take care. So if the length of the string is like 100,000, right? So there are so many homogeneous substrings are possible. So that's why, and it may not fit in the integer range, right? That's the reason why they're asking us to return the modulo 10 to the 9 plus 7. So that's how we are going to look at it, right? So now let's go and look at the code and then we'll come back to the time and space complexity for this. So as it said, the modulo, so we are saying modulo is equal to 10 to the 9 7. So I decompose that into a number, and then we are going to keep track of the long count and a current count, which I'm assigning to 1 to start with. So I will be going through the string starting from the character 1. Okay, first character, basically uh, first index, not the 0th index. Normally the strings are 0 based index in C sharp, so I am going to go with the start with the index number 1. I assign the current count to 1, right? So why I'm assigning like that, right? So basically the first character, I'm assuming, okay, with the first character I can make one homogeneous substring. So that's the reason why I'm assigning the current count to 1. So if you see, if it is single character, all how many number of homogeneous substrings you can make? Only one. So just to leave that out, I am assigning the current count to 1, right? So that's how. And in this for loop, we are going through this index 1 till index length minus 1. So first thing first, what we are going to do is, if the character is same as the previous character, if so, we are just going to increase the current count, basically, right? But if not, what we are going to do is, we are going to get the homogeneous count, that is essentially doing this formula, applying this formula, n into n plus 1 by 2. So if you go down, right, it is simple. Current into current plus 1 by 2. That's it. That's what it is going to give us. So that is what is the homogeneous count for the substring. And it is going to get you all the homogeneous count. And if that count is very large, what we are going to do is mod it, modulo of 10 to the 9 plus 7. So that's what I'm going to do here. Modulo, right? Modulo of the mod value. So mod value is this much, whatever it is there, right? So we do, that is a homogeneous count. And add that homogeneous count to the count that we are keeping track. And if after adding the count, right, if it is a really large number, then do the mod again, just to make sure we are not missing out anything. So the count will be appropriate. And after that, we are going to assign the current count to 1. Why? Because the previous character streak ended. So now we are going to start with a new character. That's the reason why we are assigning to 1. So this will be going through the end of the complete string. But what we are missing here is, so for example, if the string, in this case, it is ending with 2 characters, right? So we need to do the similar calculation again at the end, right? So we need to do the similar calculation at the end also. So that for that purpose, I am having another thing. This is just repeated here, right? There is an optimization part possible here. Basically, the code optimization that is possible, just to not repeat these in multiple times. That probably you can do on your own. But here, just for the increasing readability, I put it 2 different times. It's exactly the same code. The only thing is I have the different parameter name, basically the variable name, right? Good. So basically, once you do the same thing here, you return the count, right? So it's as simple as that. So there are 2 steps. So in this step, we are keeping the count incrementing. As and when you see a different character, you are going to calculate the n into n plus 1 by 2 and keep adding. The only extra thing that we are doing is doing the modulo to the 10 to the 9 plus 7. That's it. So that's how we are going to get the correct answer. So now let's go look at the time and space complexity. So, so let's say string length is equal to m, right? String length is equal to m. So we are going through the entire string only once, right? In this one for loop. That means order of m. And are we doing anything? So we are going through this calculation n into n plus 1 by 2, right? So that we don't have to really worry about that. So we will say time complexity will be order of m, where m is the length of the input string, right? And space complexity. Are we using any space here? So we are using few variables, a mod variable and a count variable and a current count variable, right? So apart from that, we are not using any storage, right? So for that purposes, what we will say is space complexity will be order of one. That will be constant space, right? So that's how we are able to solve this particular problem. So when you really look at the problem, it looks confusing, especially from this explanation here, right? But you can make something out of this explanation and decompose into the way that we have seen like this, and then understand how we are going to convert this to all these representations and get the count by using the sum of the first n numbers formula. That's how we are able to solve it, right? So if you have any further questions, please post them in the comment section below this video. I will get back to you as soon as I can. I have posted this code to the GitHub repository. You can find the link in the description section below this video. Please subscribe to the channel and share among your friends. Please click on the bell icon so that you will be notified about all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.